explore different ways of doing computational social science. I'm very excited to take some time today to talk through um, questions of natural language processing and related topics. And to do that, I want to set up the scientific context. You'll probably notice that Bastian and I are a good team because I'll talk about the science and Bastian is very good at supporting on the details. So this summer, when Lupita Nyong'o appeared in the hit film Homer's Odyssey, American politicians and business leaders with no actual
Nathan,
knowledge of classical
just
Bastian?
very briefly, you have the zoom button overlay like as a black bar for us in the middle of your slides, if you can move them to the
Oh,
sides.
is that gone?
No, at least for me, there's still a big black. I think it's the hovering buttons.
Let me try one more time. Okay. How is that?
Yes, no overlay now. We can see the full
It's
slides.
fine now. It's fine.
Oh, good. I'm glad. Um, so yeah,
Thanks.
these politicians had no actual knowledge of classical Greek culture, and they were complaining that the film would cast an African woman in a story that actually involved a sea on the African coast. But what they were really debating was which people and cultures have value and deserve to be made visible in media. They were debating the issue of representation, something we talked about 2 days ago in respect to Wikipedia. Uh, I've already introduced a little bit about myself and the lab. And one thing I should note is from the very beginning, Cat Lab's research has examined questions of representation, studying how cultures and values are included in science by creating pathways for people to bring diverse perspectives into science. And today we're going to talk about how to study representation on Wikipedia through a series of exercises focused on analyzing gender representation. I'm sure you would have seen some of them in the documentation we shared. Now, before we talk about the data, I want to summarize some basic ways to think about representation and fairness in the media. The Wikimedia movement has a shared vision of a world where every human being can freely share in the sum of all knowledge. This is a beautiful idea, and it's quite challenging to accomplish in reality. Unfortunately, not everyone agrees with this vision, and many people have strong opinions about which people, cultures, ideas, and identities should be shared with the next generation. So I'm a Guatemalan American of Mom indigenous background, and this is an image of what's called the Madrid Codex, one of four remaining paper books written by the Mayan peoples of Central America in what we call Mexico, Guatemala, and Belize. The glyphs represent concepts, numbers, and sounds. And for 400 years, Mayan communities actually lost our ability to read and write our own language because a priest burned all but four of the books in the 1500s. And to this day, indigenous people are seen as lesser in some parts of Guatemala. And it was only in the last decade that an indigenous woman appeared on the cover of a Guatemalan fashion magazine, Maria Mercedes Coroy, who was the actress who played Namor's mother in the film Black Panther: Wakanda Forever. Mercedes Coroy does have a Wikipedia page, one of 1,524 Guatemalans who have Wikipedia biographies, and one of the 24% of biographies about Guatemalan women on Wikipedia. Looking at this chart, you can see that most of the biographies associated with a given country on Wikipedia are about men, that area or highlighted in orange, roughly 69 to 82% of biographies. This chart shows for biographies associated with a particular country, what percent are male and female. Now, these disparities are at different scales because Wikipedia also represents some places more than others. For example, notice that Burkina Faso has 1/5 of a single percent of the number of total biographies as the United States, which has 472,000 biographies. And Nigeria has 2% of the number of biographies as the US. So people talk about geographical and cultural representation alongside gender representation. These kinds of debates ultimately wrestle with questions about the purpose of media and information in society. Are they a mirror to reveal ourselves and each other? Are they a lens on people with power? Or do they help us imagine who we might become in the future? Here are a few viewpoints I've found helpful when thinking about representation. When I was an undergraduate, I studied post-colonial literature, and I read ideas and stories of people who work to broaden whose voices get heard in society. I think sometimes of my PhD advisor's friend Binyavanga Wainaina, who critiqued how Westerners write, read, and fund African literature, and the work that he did to create communities and publications like Kwani to change that. My teacher at the time, Priya Gopal, has written about how even this story of colonial subjects and post-colonial countries trapped by gaps in media is not entirely accurate either, and how resistance to colonization actually forced the British to develop Western ideas about freedom in the 18th and 19th century. Ideas that we think of as Western, but which actually had a colonial origin as well. Rather than seeing post-colonial cultures as under-resourced, we can think of our cultures as carrying great wealth and maybe erased or under-acknowledged. The philosopher Miranda Fricker calls these questions about epistemic justice. We can ask ourselves how a group is depicted in the media. We could debate bias, whether the media favors one group or another, and we can look at the deeper question of whether people are represented and understood as they should be. And what's interesting about Wikipedia and the movement is that the mission statement contains all of those debates in a single phrase, a vision of the world in which every single human being can freely share in the sum of all knowledge. That attends to both the people who are being represented and the people who are trying to learn and exposed to information. Now, in addition to gender, researchers have studied many other dimensions. For example, researchers at Oxford studied the question of geographic and language equity in Wikipedia. In this article, Martin Dittus and Mark Graham ask, are the most detailed representations of this country written in a local language understood by the population or in a foreign one? That's a definition that you can imagine converting into data, which in fact these researchers did. And what are the consequences for community of being underrepresented in Wikipedia? In the case of gender bias, readers might hear less about women's achievements. Large language models and other AI systems might learn gender bias. Women's potentials and opportunities might be diminished as a result. And with opportunities are withheld from women, there's less to say about them on Wikipedia, which continues the cycle. Now, when trying to study representation, researchers have uncovered many layers that contribute to the gender disparities on Wikipedia, both social and technical, what we call socio-technical issues. By showing how these layers affect gender, I hope to help you think critically about other topics too. I think about these socio-technical layers like I think about the layers of a slide projector or any visual image projection. This is an illustration of the very first color photograph, or at least the first attempt at one, developed by the scientist James Clerk Maxwell and demonstrated at the Royal Society in the 19th century. When Maxwell learned that the human eye has receptors for blue, green, and red light, he realized he could make color photographs by taking pictures of each color and layering them on top of each other. Media is like that. There's the ground truth of actual people in their lives, and then there are the layers that form the picture we have through media. As it happened, Maxwell got it wrong. He didn't know it, but his chemistry was flawed. When scientists tried to reproduce his technique 100 years later, they learned it didn't actually work and created a distorted image. And that's our job in research, to understand how issues at any of these layers can create a distorted understanding of the world. And hopefully our distortions are not a problem as much as we hope, or we hope not. People often start thinking about a problem of representation when they learn about a clear and obvious problem at the surface layer. Women are underrepresented on Wikipedia almost every way you measure it across many language editions. The percent of articles, the percent deleted, the length of articles, language, classification, and even the structure of links on the site. And when people learn about this, they often next ask, how did differences in the opportunities for women shape this problem? Is this just the state of the world? Out of 145 countries, 27.2% of women are elected to national office where elections are held, and at a local level, women constitute 36% of elected members. Only 2 countries have reached 50%, but they have, and an additional 26 countries have more than 40% women in local government. So even in just politics, Wikipedia is behind the state of the world. Now, in between the ground truth and the contents of Wikipedia, one of the layers is epistemological. It has to do with the nature of knowledge itself. As a Guatemalan American, I really love eating tamales, which are steamed for many hours with maize, pork, or chicken, prunes, olives, peppers, and special spices. And when I asked my friend, a chef, if he could teach me how to make them, he asked his abuela, his grandmother. Her response was, "They are not for business." Because he's a professional chef with a restaurant, his family will not teach him the family recipe or allow him to share it to protect their culture from being shared too widely by people who might not appreciate it. Wikipedia sometimes struggles with a version of this, where communities don't want to make their culture available freely for anyone to read and take and reuse. Or maybe they convey their knowledge in a format that Wikipedia is not designed to cite. And this is one of the big reasons that Wikipedia over the years has struggled to include indigenous knowledge effectively. Another layer is the information supply. Wikipedia relies on citations. If you make a claim, you need to back it up with a secondary source like a newspaper or academic article. Now, this is a chart that looks at, from the Global Media Monitoring Project, that looks at women appearing in news articles. And in 1995, 16% of people appearing in news articles mentioned women across the world. That rate increased to about 26% by 2015, but it hasn't increased much further since then. And if you recall, that's roughly the percentage of biographies that mention women in Wikipedia. Information supply is a very important part of the story. If people aren't covered in the news, they can't be easily included in Wikipedia. Even when information is available, it might not be accessible for legal or technical reasons. For example, many publishers have been adding paywalls to their news sites to prevent AI companies from scraping their data. One consequence of this is that if Wikipedians can't read the article, they can't cite it or include it in Wikipedia. This technical issue also spreads to access to the internet. I mentioned that study by Dittus and Graham, and they found that over the 2010s, as access to broadband grew, local language information about a given region increased along with it. Another factor that they found drives local language production is the existence of a diaspora with high levels of internet access. And even if you have information, access, connectivity, you still need volunteers to make contributions to Wikipedia and feel like those contributions matter. So far, this kind of analysis has been challenging since we have very few reliable long-term measurements between countries about volunteering. But as groups like the UN make progress on measurement, as mentioned in this report here, I expect to see a correlation between the disposable time that women have available in their lives and the amount of hours that women contribute to Wikipedia. Finally, once people do contribute to Wikipedia, the site's own norms and policies play an important role in determining how women are represented. You'll recall Bastian mentioning on Monday, deletionists and inclusionists. My colleague Francesca Tripodi has found that on English language Wikipedia, biographies about women are more frequently nominated for deletion than articles about men, due to details in the English language policies that can sustain gender disparities on the site. So as you study what makes it into Wikipedia, think about how these layers combine to produce the picture you see, from ground truth, epistemology, connectivity, all the way to policies and norms. So how is the Wikimedia movement working to change this? This is important to know if you're thinking about who you might learn from or work with when doing research, or what kinds of efforts you might study to test their effectiveness. Wikimedians work to create technologies, policies and community organizing programs to work more effectively with oral traditions. For example, a 2024 project organized a team that held workshops, trainings, recorded oral tradition, and improved or created over 3,000 articles relevant to Hausa culture and history on Wikipedia. The Wikimedia movement is also working to improve the information supply through projects like Wiki Imagine Lagos, where Wikimedian in residence work with the Lagos state government to create a contest to highlight Lagos's cultural landmarks, tourist sites, and festivals in the media in ways that could then be added into Wikipedia. So they had a prize for people to publish in the news and other places that could be cited by Wikipedia. Wikipedians have also made progress on the legal barriers that make it hard to access certain information. This is a very cool project. Projects like the Wikipedia Library actually grant access to newspapers, scholarly journals, and other paywalled information to people who contribute at least 10 edits a month, wherever you are in the world. So if you want greater access to scholarly journals and you're constantly hitting up those paywalls, this is one way to get broader access to journals by contributing to Wikipedia. And Wikimedians are also working on the connectivity barriers. Wikifundi is a project of Wiki in Africa, who we've been working with on the summer school. And they actually have created technology for people to access and even contribute to Wikipedia in the absence of a high-speed internet connection. So they can download a large section of Wikipedia onto local devices. They can train people and support them to add content, either for their local context or to be able to share it back to the main Wikipedia. The movement also does research. There's a team called Wikimedia Research that does a survey every few years of the volunteers on Wikipedia to try to better understand the experiences and needs of contributors around the world. The last survey surveyed over 3,000 people, and this chart shows the data on the proportion of women by contributor type and tenure. So 7% of admins are women, people like Valentin, who I mentioned. But 34% of people who are trying to organize and support broader efforts within the movement are women. So you have these various roles where women have found themselves in greater numbers. And the movement also creates editathons like Wiki Project Afro Creatives, which runs a regular campaign to generate contributions on African film and television in English, French, Arabic, and African language Wikipedias. And to give you a sense of how extensive these efforts can be, last year's event had meetings in, let's see if I can get this right, Nigeria, Togo, Rwanda, Kenya, Namibia, Botswana, Ghana, Burkina Faso, Senegal, Guinea, Tanzania, Madagascar, Cameroon, and Egypt. So people from all of these regions or who cared about film in all of those regions it took time to gather together in many different locations from their homes, from local community meeting places to add to Wikipedia on film. And there are regular efforts like this every year. And Wikipedians also work to change their policies, though changing a culture does take time, care, and energy. This is a photo of the Oral Tradition Task Force, who've organized people from around the world to improve how Wikipedia's technology and their policies include oral traditions. So as you set out to study representation on Wikipedia, I hope these concepts help you focus your research endeavors. Yes, we can study the surface question of some of the things that we'll be sharing with you in the examples Bastian has, but it's helpful to know that there are these other factors at play that you might want to include and incorporate in your research in some way. Now, I've already spoken far too much about the background context. I know we're also here to think about tools and techniques, and so I will stop there. But if you have questions, happy to field them before Bastian goes into more questions about methods and techniques and code.
Thank you very much, Professor Nathan. That's a very strong background. Already we have participants whose hands are ready to ask you some questions. So just take few minutes before we go to Bastian's section. So also, our dear participants online,
The natural language processing bits, I would be curious to hear how things have been going in the last 2 days to see like how things progressed, if you had like a chance to like engage more with the materials, if we should pick up some questions you might have on those, like is there anything we should like follow up on first with like the old materials before going ahead?
okay. The engagement here has been very, very intensive. As a matter of fact, we end up overshooting our schedule, and many people also have to get back to their room to continue some other works and tasks within the house. So the solace that we have is that the material you're giving to us, we can always use it even after 6. So I'm sure many of them must haven't gone further than what we did in class, but would appreciate to continue from where you stopped. George.
Okay, then maybe to get an idea what you think would be most useful for all of you. Shall we continue a bit where we left off the last time, which means we probably don't have time to get into the natural language processing bits, or shall we just go into it even if there's like a bit of a gap in what you already know from the last lessons to today when we focus on the natural language processing?
Okay, we can focus on the language processing.
Okay, then we do that. All right, we'll share my screen in a second. Oops.
It's participant online. Open your house to charger. Do we all
Hope you
have our
can
house to
see.
open?
Yes, we are following, but myself, I'm on transit. I'm leaving my station to my home now. So I will just be following like that.
Okay.
But it is well. Thank you.
Okay.
Okay, then we will talk a bit about the natural language processing, and I think maybe given the time constraints, we just go through it without actually running the code at this point, because again, you have the materials that you need in the online materials, so you can run the
Yes.
code. And the first part will focus a bit on extracting data from Wikipedia using the pause system we saw on Tuesday. And then in the second part, we will focus on how to do some very basic natural. Can I zoom in? Oh, yes, of course. Sorry. Let me make that a bit bigger. Is this better, Nathan? And also for the people in the room, can you read well? I think that was a yes. Perfect. So we will go a bit into like first, like as I said, like going over like details of extracting some of the data in Python, just to so that we have the data we need, and then we like go to our studio, like where you can do some basic natural language processing then as well. And Nathan gratefully found out like some references that like if you're interested in doing natural language processing in Python, this book, Natural Language Processing with Python, is like a good starter if you want to dive deeper into it, and like especially if it's in the context of Wikipedia, where it might be easier to do some of this analysis in a Python system because the libraries already exist there. But maybe to just like repeat a bit of what we've seen on Tuesday already, as well as like how to query a single page in Wikipedia. So again, we can use the PyWikibot library, and there is also like a library, or like part of it is like a library called, or like a subpart that's called a TextLib, which allows you to interact and parse the output of Wikipedia, the formatting like a bit more structured, because the as you might have seen in like the past, there's like its own wiki text formatting that Wikipedia pages use. And then what we can do is we can access again, we want to like get data from the English language Wikipedia in our example. And then we get like a particular page, and here we get like a single politician's page where we can get the raw text. So if we do this, we can like again get the whole like text of the page itself, either in the wiki format, which is just the .text object of the Wikipedia object that we create, or also we can get the conversion into HTML if that's more useful by using the expand text version. And you can see an example of this here, where you have the wiki formatting with like the curly brackets. You get like the templates
Yes,
that
everybody,
Wikipedia
I'm
uses.
just looking. Hello, Bastian. Sorry to cut you.
Yeah,
I just reminded my participants here that the codes here are Python codes, right?
yeah, that's Python code here.
Yes. So I please those online, in case you don't have any IDE that can run Python code, you can quickly use Google Colab. Just go online and search for Google Collaboratory. Actually, Google Research Collaboratory, but just press Google Colab. It will come up. Yeah, so you can start putting your code there. Those online, can you hear me? Okay,
Yes,
Bastian,
yes.
please can continue.
And yeah, I mean, this again, like all of this you can run in what we saw at the last the pause system that we saw on Tuesday. So if you launch the pause system, we do put it side by side. As the Python part in any case is quite close, quite short.
Citizens, I just
It's useful to put the link in the chat again if people need that one. So we get the page, and then what we do is we look at the raw wiki text. Let me just actually make this full screen and zoom in a bit for you here. There we go. So we can look at the wiki text itself, which then is in the formatting that like has the like info box bits, like these templates that Wikipedia uses to format pages. But you can also get it converted into HTML, which then if you're interested in like reusing maybe some of the things you use for web scraping, you could like access those ones. And the last thing we did is we look at the sections. So you can extract from an article all the different sections, and sections are the headlines and like the content within those headlines. And if we do this for this particular politician, what we see is that here's the like different sections. So it has the early life and education, political career, when they were in parliament, their political career after a certain date, responsibilities, and also like information about like the person's personal life, if that's part of the Wikipedia page. And following on what Nathan talked about earlier, like one research study that one could think about is like exploring whether male or female biographies in Wikipedia are more likely to contain a section about a politician's personal life or not. Because they're like, as we've seen, like in some places, this might be the case that like there is more like details about a person's personal life for women about like not their like career and their work, but about the personal life than for men. So we can do this again, like, and can answer this by just looking at these sections. So is there like a personal life section in a Wikipedia article? Yes or no? So that's quite easy, like in the level of like the language processing we need to do. And basically this now we do not have to go into a lot of detail, because what it does here is that like there is like a bit of code here that like gets from Wikidata a list of different politicians, and in this case of Kenyan politicians again, both like a set of I think 20 male and 20 female politicians, which we get from Wikidata, and then we just convert this into like a table. And for each politician, we get their gender and we like get if there's a personal life section included or not, just by iterating over this data, by looking at what we do here is we extract the sections of like the Wikipedia text and see if there is a personal life like headline or not. And it's very simple. We just like search for, in this case, very naively for the text personal life in the section titles. And if we ever find it, then we say this article contains it, and otherwise we say it doesn't. And maybe to just very briefly like look like get into like these details is why we use Wikidata is because it allows us to query like a very structured database where you can look for people and for biographies of people who might or might not be on Wikipedia based on very structured characteristics. And here's like this like example queries. So there's like different characteristics and that describe an object, and an object can also be a person. And maybe what we quickly do to better explain this is to just go to the Wikidata materials here, which like, so you at least get an idea of what Wikidata is so that you can like make the connection for why this is important. And so Wikidata is a very structured like knowledge graph, which like has like items which are described by having properties, which in turn have different values, and these values can also be other items. And as such, you have this knowledge graph that describes an item by having very structured data. And to make it a bit less abstract, make this big for a second. Here's an example that Wikipedia uses to describe these things based on the British science fiction author Douglas Adams. So Douglas Adams as an object or item on Wikidata is described by these different statements. And a statement can be a property like where was the person educated? And then you have different values for these particular properties. So the property for educated at has actually two different values here. There is like the St. John's College and the Brentwood School. And each of these statements can be further qualified by when a person like started or ended. And if this was like being member of a parliament, it would maybe be which like legislative period they were in parliament. And because it's Wikipedia or like a wiki project, references are very important as well. So you see people put in references about where this information comes from. How do we know that Douglas Adams went to St. John's College between 71 and 74? And it gives Encyclopedia Britannica the URL and when this information was retrieved. And so collectively with this, you can then actually start querying for information using what is called the Sparkle query language, which I think the Wikimedians also talked about a bit on Monday in their presentation already, which then allows you to find information in this big database that is Wikidata to get objects. And like, do we have the example query? So in our case, if we are interested in finding politicians, then what we might be interested in is finding, first of all, objects which are people. So it needs to be a property and value that translates to being an instance of being a human and not being something like an airport, a cat, a dog, because all of these things are also part of Wikidata. Then we might be interested in only people that have a given occupation. So you can look for like this property 106, which then lets us look for people who are in the database as having the occupation of being a politician. And then you can also filter it down by looking for people based on their country of citizenship. And in the examples here, like what we have is an example for doing this for, again, like Jomo Kenyatta is an example where you can see the statement is instance of being human, occupation, journalist, and politician, and country of citizenship. And you can make these queries yourself online using we have it here now. Somewhere there is the link to the query builder where you can make your own queries for Wikidata, and let's copy and paste the one for, oh, maybe just make it here. There's like some examples that you can use for like finding like different objects in Wikidata, and this could be finding articles of or like items of cats that have pictures attached, finding hospitals, finding a lot of different information. So the Wikidata query service helps you generate these queries you might be interested in, and you can just pick one and run it, and then you get the results out of it. And so now you can actually start editing those queries yourself to find the information you are interested in. So instead of finding a cat, we can find people who are human. But of course, if we were to run this, the problem would be that like we get every single human in Wikidata. So like this would overwhelm the database. So we are not trying this out right now. But so you can actually start building these queries in that way and start getting data out of Wikidata for your own research. And now we can go back to just like explain a bit why we did like this whole complicated looking bit, because we were interested in finding like particular information about particular people in Wikidata to extract the information to make our research data set that we can use to then understand if like male or female politicians have more or less mentions of their personal life in Wikipedia. So we got everyone who is a human, who is a politician in Kenya, and then we did it twice, once for people who are male and once for people who are female, so that we got like a data set that contains like people in like the correct articles, so that we have the gender available, and then we got this table that allows us to compare this. And if we do this, we can just basically make a count. And in our case, for the example of looking all the Kenyan politicians that are represented in Wikipedia, at least in the English language Wikipedia, we get that in our small, very simple example, there seems to be no difference. So we see for like female politicians, 33 articles include a section about personal life, while 131 don't. So that comes out at around 20% of articles mention the personal life of female politicians, and 89 out of close to 500 male politician articles have the same section, which is around 80%. So in this case, we don't see a big difference. And then now we've done like a very simple like analysis right here in the pause system again. And now maybe the next thing we want to do is explore the references that are used to make claims about people on their Wikipedia pages, or do some web scraping instead of getting the pages from the API. And for this, we now just, what we do here is save the data we got as a CSV file that we can download and then reuse later on in R or RStudio. And that's what we are gonna be looking at now by like going back to the materials here. We have like a small section about how to do the web scraping in R and do some basic natural language processing. And of course, for Wikipedia, in reality, that's not really necessary because there are those APIs, so you should not need or engage in web scraping for Wikipedia, as there's better, more sustainable ways to do it, and that are also giving you better quality of data in a way. And as Nathan also mentioned in his talk, just like now earlier, was that like it's increasingly hard to do web scraping because of the load of scraping done by companies to train AI and so on. So it's currently not as easy to scrape the web because often there's like paywalls or these like anti-scraping methods in place. So that's one issue. So we will now just like again try to like do the scraping just as an example, but again in reality, like for Wikipedia, it's not necessary. And I think you probably have already done some work in R this week, so you will have probably already set up most of these libraries, especially the tidyverse, which is like this meta collection of libraries which are used very widely, that you probably have seen and interacted with already. but there's like 2 or 3 libraries that are specific to like the web scraping and natural language processing that we need to engage with. And one is called RBEST, which is for the actual web scraping, which you give it a website URL and that then gets the data and allows you to interact with those web elements. And then there is a library called word cloud and tidy text, which we then need to process the data and visualize it. And then what we can do is we just load the CSV file that we've just created earlier in Python that we've downloaded to then interact with to scrape a single Wikipedia website. So we just save all the politicians in this data frame, in this table, and then use a single politician's name to access a single Wikipedia page for a single politician. And these libraries work quite easy, at least for reading the data, because all you need to do is use the read HTML function, giving it the URL you're interested in, and it already gives you an HTML document. Now, of course, the tricky bit is that you need to somehow figure out how to extract the information from that page. And that can be quite complex depending on how the website is structured and how easy it is to get particular elements from the website. And we can follow along with this maybe by actually in a new page. So we need to now somehow find the sections we are interested in the website. And in reality, the best way to do this is by using the web developer tools of the browser you are using. So this is now in Firefox, but it will look quite similar in Chrome or any Chromium-based browser, which gives you a way to actually look at the website code at the same time. And importantly, it allows you to find out how different parts of the website, like how the markup of the website looks like to identify what you are interested in, that you can then use in your code to engage with the scraping. So in the example of the references that we are interested in for politicians now to see like which websites or which media talks about a politician, if we just scroll down a bit, we can see that we have the section of references here. And if we highlight it, it already gives us some level of like the information of what we can use to access the politician's reference or the reference section on this page. And you see down here, you have like the section ID. Let me try to make it even bigger as I think, otherwise it might be very hard to see. Is semi-readable at least. So we see that like the section that includes all the references like has like this like area labeled by references. So because the way the headings work, it is like the ARIA thing is like a way for like screen readers. It's an accessibility feature of websites, but it gives us here like in a very easy readable way the heading of the sections that we could, for example, use to extract the information from the Wikipedia page in this case. Because all of them will have like if there is a section that's called references, they will always have this ARIA labeled by references bit that we can be using. And then we can do in the R code here on the left is like we have the HTML that we've saved, and then we can try to extract the elements based on what's called the XPath. So what's the different selectors of like these subsections and different sub-elements that you can access. So in our case, we say we want to get the part of the website that starts with a section that contains in the code. So here's the section is like the top level tag, but then it needs to have the property of having the ARIA labeled by object, and the value needs to be references. And if we do this, we already like break it down a lot more, that we only get like the part from the website that is basically everything that's the the blue highlighted bit here and not any of the other text. So this makes the scraping a lot easier already now because we have a quite defined and narrowed down things of just the references. And then if we look at the references themselves, we can see that they are in what's called an ordered list in HTML because they have the numbers at the beginning. So if we are interested in just extracting the references, what we can do is we look for the ordered list, and every list element, which starts with the li HTML tag is like a different reference on our page here, which we can use to scrape again. So once we've identified that we have like, okay, the references are all part of an ordered list and each list element is a reference, we write like another XPath to extract this information, to get all the elements that are part of this ordered list and are in this element, and then that have are containing the class reference text. Because if you like open any of them, you will see that the actual text of the reference then further down is not just part of so that like the references rather have like many different like small subparts to it. So if you look at the things, they have the number itself, the marker, so which number of reference is it? They have like the backlinks, so where in the text there's like a, let's use the second one, which is a bit more informative, but which gives us the like where in the text are these references appearing. So in this case, there's like
Okay,
7 different web
Sebastian,
references. Yeah,
please can I just chip in a little? I want to confirm for my online participants if they are following. Please, those online, are you
sure.
following? It is trying to build the scraping style. So I don't know if you remember when Mr. Anson was teaching yesterday, he was mentioning div tags and the reference of the div tags. So Mr. Bassin is showing you how to get the div tags and the references by inspecting the websites that you want to scrape from. So I hope everyone understand online. Do you understand? Those online. Those in-house are following up already. Those online, do you understand? I need to hear a response.
Yeah, we are catching up.
Okay, okay. Thank you. Okay,
Thanks.
Bastian, please can continue.
Yeah, no worries. So we now basically just identify the parts again that we are interested in, which are the actual reference texts here, and they all have at the beginning, they are part of the reference text class, so we can get those bits and then get the actual citations that way. And this then allows us to get from the page here that we are seeing, you can see this list of the 22 references, and we can extract very easily by just using what we've like looked at in the source code of the website. We can get the full list of the references on this page. And at first glance, this might look okay, but you might have noticed, if you have very sharp eyes, that there's like at least one citation that includes this weird HTML formatting still. And this is because of how Wikipedia citations work. There's different ways of make citations in Wikipedia. You can just write the citation using the like very simple built-in references, but there's also a way to like use these templates, which are with the curly brackets that like allow you to give more structured metadata to it. And if people use those, there will be some of like the extra like citation formatting that makes it a lot harder to work with the citations. For now, we will ignore this and say, like, let's see what happens, but like we will see later how we can remove this and like try to resolve the problem. But it highlights the problem where if you do web scraping is that it's very hard to account for all the edge cases of how the formatting changes if you get this to some extent more unstructured data than you would get from an API. But for now, we can just use the tidy text library and the word cloud to like get a very simple first analysis and see what happens. So we load the tidy text and word cloud library, and then what we do is we tokenize our text, because currently all of this is just text, whoops, normal text that's just like in like whatever reference, like it's like a continuously flowing text. But to actually make a comparison between different articles and to maybe see what's the most common words, we want to tokenize things, which is just breaking it down into words or like smaller tokens instead of having the long text. And in this case, we can use the function called unnest tokens, which is part of the tidy text library. And what we do is we just give it our like data frame with the references and ask it to make this tokenized list instead of having the like flowing text as before. And then you can also continue doing things like just counting the words that you already see in these tokens. So you count how often do different tokens appear, and then turn this into like a new data frame in itself. And what we did here is having exactly this. So we look at just the 6 most common words that we found in all the references for this Wikipedia page on the right. And you can see that there's like many weird things that we like have in there that don't make too much sense. And part of this is what's called stop words, which are very common words and prepositions and things like this, which don't carry much information once you tokenize things. So you typically remove those. So that's like the, on, from, and so on. And an easy way to do this, again, like the tidy text library like gives already a data set of common stop words for the English language. So you can just load the data set from that. And then you do what's called an anti-join. You only keep words which are not found in the second data set. So you take your data frame of all the references you see on, or like all the words you see on the Wikipedia page that you've extracted, and you compare it to the list of stop words, and you only keep those words which are not part of the stop word list. So basically, whatever is in the list of stop words gets removed from your data set. And you can see this like removed, in our case now, only a single word that was like part of the stop word list, which is the article, which is very common, but it leaves us with like a lot of like these problematic labels that come from the citation markup, as I have explained, which we might want to remove as well. And for this, you can create your own filter list, which can be your own stop words, which works then very similarly. In our case, we just create a list of words that like appear in like these markups, like the MW for media wiki, the parser output. We have like the color information because that's the skin Wikipedia uses, so the like how it looks like, and it's like the skin Wikipedia uses by default is called Minerva, and it has all of these words and like code that we're not interested in. So we just create a list based on what we've seen in the scraping, and then we can do the same like anti-join to remove our own custom stop words from the tokens that we've generated. And now it's starting to look a bit more like a list that's somehow meaningful. So Kenya now makes like the list. We see that Awori as the last name of the politician appears. So with this now we can just go and make like a very simple word cloud by printing out the tokens and say put it into a word cloud, and there's some formatting to make it look nice. And then what we see is a word cloud like this. And if now we look at it, we can see that there's still some strange things. So like some of these artifacts that come from the way in which we did the citation extraction because of how the weird HTML formatting that's part of some citations remains in there. So for example, we get like some error information, we get the HTML body, we find like some of the like repeat URL information, which like should not be in the word cloud if we had like done the reference extraction a bit more carefully, or like a bit more structured. So like we can now basically go back and say, let's try to redo the citation extraction, but how can we explore the like which bits are in there that we're not interested in? And first of all, an easy way to do this is to say we again get all the references using the everything that's part of the ordered list is a list item and is a reference text, just as we did before, basically get the same type of list. But then what we do is we can ignore all the rows that contain this MediaWiki output that has the weird formatting that should not be in there. And for this, we can do a filtering step where we filter for everything to only keep things that do not include the MediaWiki parser string in the output. And then what we end up with, if we look here, is the data frame that contains now the references. And you can see it's now only 21 instead of 22 because the one that included the strange formatting has now just been ignored. But of course, we aren't interested in all the citations, so we need to get those back that include the strange formatting and make sure they are just properly parsed instead of keeping instead of removing them or keeping the strange formatting. And in this case, if we look at them again, and I think it was this one, we find the bits that contain the reference text, but then we go down deeper and say include the things that have or only get the bits that are within the site class below. And that way we end up having the content here from the HTML or the wiki template formatted text that's more readable and makes it easier to see. And then we can go ahead and join these two lists that we've now created, one that has the simple citations of Wikipedia, one that contains the templated citations in Wikipedia, and turn this into a single data frame. And if we do this, we end up having a list of the full list of references, and that allows us to now work with this and redo the tokenization and create the word clouds without the weird artifacts in there. So we again do the tokenization. We use we unnest it and we create the same data frame as before, and we again remove the stop words. And now we have a list that contains the again ordered by the frequency, which are the most common words, and we plot the 10 most common ones. And now the things like the URL and the other HTML text that we've seen before are not part of your data set anymore. So now we can have a data set that's at least more useful to work with based on just a single page. And things that, for example, bubble up now is the Standard, which is one of the main Kenyan media outlets. You have the BBC and so on. And now we can redo the whole thing. And again, as we've done in the past, or before, we can do this on a sample of 20 female and 20 male politicians, so we don't overscrape Wikipedia for our example. And what we do is we get a list of only the male politicians. So we filter our data frame down for male politicians and one for only female politicians, and then just pick the top 20 for each of them and get the names so that we can do the scraping. With that, we can now write a small R function, which does all the different steps we've done so far manually, in which we just want to pass the list of the politicians, or pass a single politician rather. And then what it does, it gets it creates the link to Wikipedia that we need. Then we read the whole Wikipedia page. We find the reference section, so the full reference section that includes all the information of the references, and then get all the references once and get the ones that including the ones that include the markup, and create one. So, and get this full list of references, and then we get a sub-filtered one that contains only the ones that are not formatted. Again, get the ones that have the HTML or the Wikidata, Wikimedia, MediaWiki formatting template, and then create this joint data frame as we've done before and return that as a data frame. And so now every time we call this function, we get like an already cleaned up list of references just for every single page that we like feed into there. And then what we do is we can just very simply iterate over every single male politician and create a data frame that grows about like by appending the references for each of those politicians by just saying we take the existing data frame of like all the data we've gotten so far, and we append or bind at the end the references for the current politician we are scraping. And then if we run this, we just get like a list of like the pages that were included, and we repeat the whole thing for female politicians. And then we have two data frames, one that includes all male references, one that includes all female references for female politicians. And then we can go ahead and tokenize those. So here we just write a very small function as well for tokenizing the data frames we've got so far in the very same way as we've done before mostly. So we unnest things into tokens from the full text we got. We remove the stop words from the stop word like data set that exists already. And then we also remove some of the extra words that we saw appearing quite often because they're also just part of how Wikipedia formats its references, which are like the retrieved on a given date, archived on a given date, and the Wayback Machine, which you can see here. You have like the archived, you have the date when it was archived, the Wayback Machine, and so on. So just to make sure that we don't like keep more of these artifacts, such as like the way Wikipedia formats references, remove those as well. And then we get at the end our tokens. And now we can tokenize the male politician references and plot them and redo the same for the female politicians in the same way. And if I zoom out a bit, we can make a comparison. Oops. Maybe what I do instead is open a second window so that you can compare better. Zoom in again. Oops. So female politicians and the male politicians. Okay, for some reason it's not going to get bigger. So if we compare the male and female politician references, what we can see is at least a bit of a difference already here. Even just using 20, we see that, for example, the topic of women appears exclusively in, or the word women appears exclusively, at least at a high rate, in the female politician articles and not in the male ones, while male does not appear in the male politician's article. But of course, being Kenyan politicians, Kenya is the most frequent word in either like category. And so this is a very simple example of just how you can do like a very simple scraping to like look at the Wikipedia references, format them a bit. And of course, there's a lot more cleaning that would need to be done to make this useful. Because, for example, you could be interested in just looking at, oops, if we come back here, at like what's the outlets, so which like media is quoted in Wikipedia articles. So instead of taking all of it, you could then go and try to extract the titles of the media outlets, or you could be interested in the age of like when like the things were published, because most of these articles will include the publication date of the media as well. That's like another thing you could extract by tweaking the scraping. So far, we've just taken the whole text, but of course, you could equally just look at like particular subbits of it based on the formatting. So this is just to give you a very like high level idea of like how the scraping can work and how I think mostly it's not very easy because increasingly websites have very complex markup because of how technology has moved to using a lot of like JavaScript-based frameworks for rendering websites. So Wikipedia is comparatively easy to scrape compared to many more complex websites where it's becoming even harder to get information out through these technologies. And then the last thing we want to look at is to do some very simple sentiment analysis where we are now that we have these pages are interested in understanding how do people talk about these politicians on Wikipedia. And sentiment analysis is quite a complex field, which is not necessarily intuitive to understand. So I think there's like many moving parts to it, which we cannot get into detail here. So on a very high level, sentiment analysis works by assigning what's called emotional scores to different words that you can use to score text fragments to figure out if a text has a positive or negative opinion in a way, or get insight into whether like a text is emotional or how emotional it is. So it's to some extent like a bit subjective in that sense, and it's all done based on using reference lexica. And each of these lexicons has like basically a list similar to how we have a list of the stop words, a list of words that have been scored in a particular way for like their sentiment. And then you can use those lexica to score your existing text of interest that you want to work with against those lexicon. And the text data package offers many different lexica you can work with. And to do a very simple example of that, what we do is instead of scraping from Wikipedia on the references, we can scrape the full article, like the full article that contains the actual text instead of just the references. And in Wikipedia, that's actually like comparatively easy to do, luckily, because basically all the elements we are interested in are the paragraph elements. So if we, for a second, go back to the Wikipedia article, you can see that each paragraph in Wikipedia, if we hover over it, you see at the bottom here, like all of those are individual paragraphs. So unlike the references where it was somewhat complex to extract the information, for getting just the full text of the Wikipedia article, we conveniently just need to like filter for the paragraphs and extract the text out of those. The only thing we then still need to do is remove the references or the citations rather, because you will see that like these include like the little in angled bracket, the actual link to the references. So we remove those. And then in the end, we just get like a data frame that contains all the paragraphs from a given Wikipedia article. And as we've written this as a function, we can now, just as before, iterate over the page content of all of those Wikipedia pages. We can do this again for the male and female biographies that we have seen on Wikipedia. And now we have the full text and can, just as before, we unnest the tokens to just turn it into individual words, and we remove the stop words, which will not be informative for the sentiment analysis. And then we have two data frames, one which is the like for female or male politicians, the cleaned up tidy text that we can then use for our sentiment analysis. As I've said, there's like many different data sets you could be using for sentiment analysis as the lexicon you compare it to. And a very simple one that you can use is the Bing, it's called the Bing data set in the tidy text or in the text data package that we can use. And it's a binary classifier. Like each word that's part of the corpus or of the lexicon of the Bing data set is scored as either positive or negative. So there's no like numerical scoring. It's just positive, negative by like label, and that's it. And then what we can get is like from the text data package, we load the lexicon using the get sentiments function using the Bing data set. And then what we can do is we can join before we use the anti-join to remove data, which was appearing only in one of that did appear in one of the data frames. So we said if it's in the stop words, we remove a word with the anti-join because we are not interested in words which are part of the second data set. here what we do is do an inner join that says we only keep words which appear in both because we are interested in scoring the sentiment. If our any words from our Wikipedia article don't appear in the sentiment text, we ignore them and we only keep the words which are part of the Wikipedia article. And then what we can do is we can print just count the sentiment words for each of those. So for the mail articles, we can make the sum effectively of how many how many positive and how many negative words appear. And for the mail biographies about the politicians, we see that it's 123 negative words appear while 120 positive words appear. So these overall seem to be more or less equal. And if we do the same for the female politicians, we see that the total count is higher, but that the ratio between those two again is the same. So it seems that using at least this very simplistic analysis, there's not a marked difference we can observe between male and female politician biographies in Wikipedia with respect to the positive or negative sentiment. And this is really just to give you a very quick overview of what can be done with this. And it's important to highlight some of the problems and what things you could be doing differently or improve if you take this to get started. And one thing for the sentiment is that, as I've said, there's many different lexica you could be using. We've used one that just does a binary classification, but the library we used also includes what's called the AFIN lexicon, which scores each word that's part of the lexicon from a range of -5 for very negative sentiment to +5 for very positive sentiment, with all the values in between, all integers in between. So you can have -4, -2, 0, and so on. So if your analysis wants to engage in a maybe more numerical analysis, that could be a way of doing it. And then there's also a data set called NRC, which not only gives the positive and negative sentiment as categories, but also this list of emotions, things like anticipation, fear, surprise, trust. So you can get a different sense of what people are in a way talking about in an article. And of course, which lexicon you can or should be using depends on your research question. And these are typically quite well documented. So if you look at the library, each of those has a reference of where the data comes from and also the license terms under which you need to use those data and so on. Then another thing we have currently not taken into account at all is negations. So if a sentence includes saying someone is not happy, we would still count this now falsely as a positive sentiment because we saw happy, but we did not understand that it had a negation in front of it. And if you think about the tokenization we did, we said we tokenized using the word level. So we just looked at the individual word and not whichever word might have come before. And using instead of a single word analysis, you can do what's called a bigram analysis, where instead of tokenizing on the individual word, you look at the two succeeding words. So in this case, we would keep the not happy together. And if the way to do this in the unnesting function is to just say you want to tokenize on the n of 2 instead of the n of 1, and then you can actually make these comparisons and either filter out negations or invert the scoring depending on your research question. Then the last thing is that currently we've done a very, very simplistic summary statistic over all articles, all words in all female and all male biographies and just giving us a single number or two numbers for positive and negative sentiment. But of course, you can also start breaking this down on a per article statistic. You could be looking at each individual politician and say, is there differences in sentiment between male and female politicians, not only those, but also between political parties or between other individuals which have a particular positive or negative sentiment. Or you could even do this on a per paragraph basis where you go through the different paragraphs and see are different sections in an article having a different sentiment. So there's many options in how you can tweak these analysis. And if you need more information, there are some really nice beginner guides for how to do sentiment analysis in our online as well that can help you get started and help you like do some of these like alternative suggestions to better understand things. And I think that's pretty much what we have for the web scraping and sentiment analysis. So happy to now take questions on this, but also, of course, on whatever we did on Tuesday if you need more information and more help there. Thanks. But now I will stop the screen share so I can see all of you again. Any questions in the room or online?
Um, for
Everyone getting ready for lunch?
that's, I think we are still about 11 minutes away from there. So for our participant in-house and online, Bastian is asking if there's any question. I don't know if you people would notice. We've had session with Bastian, we've had session with Joseph, and we've also had session with Aston. And you realize that there are repeated processes in those three sections. First of all, there's what Bastian was trying to do, which is data cleaning. Data cleaning, and one of the things you do in data cleaning when you are preparing your data set for large language models is to remove stop words. And stop words are words that does not really add meaning to your entire text data set. Example, the, anybody could have conversation and like within a sentence you can or within 2 or 5 sentences or a page document you can see D 20 times. You understand? Whether you're talking about politics or you're talking about health or you're talking about finance. So they are not words that really add value to the data set. So Bastian has helped us or reminded us again to see how you can remove that. Then also in answering section, you saw how he was making reference to the structure of a website. Ideally, when you want to do web scraping, the first thing you need to do is to inspect the website to understand the structure. And Baston was able to achieve that for us by inspecting the website. It showed us the structure where we saw the that's where we saw the div tag, and you could even see more tags there, the li tag, the span tag, and frequently they also use the paragraph tag, which is the p tag. So that's what Bastian has also helped us to achieve in the work that he has shown us so far this morning. So I don't know if there's any point where any of the participants was confused. You can ask Bastian question for clarity. I know you have the material already, so you are following up. So I think it's easier for you to understand. Okay, online participant, do you have any question? Mr. Anthony Ibe, I can see your handsome face. Anthony Ibe, it's Anthony. Anthony Ibe, Emmanuel Lipin. Okay. Okay, so we want to assume that. Okay, Bastian, you want to say something?
No, I think like what you said about like the like one of the big like shared tasks, like no matter what you do, like when it comes to any computational work, and in particular computational social sciences, is just the cleaning the data. And like I
Yes.
think like where I used to work in London at the Turing Institute, we had like a whole team of like research software engineers that were just called the data wranglers. And they
Yeah,
spent
data
all day,
wrangler.
every day, just cleaning up data for different research projects. And I
And for me,
think that's
that's even the most difficult part of data science and AI engineering. Because if your data set is not cleaned, you might not have a good model result.
yeah. So I think that's just to highlight that if you think you like spent a lot of time on like cleaning data and you struggle with it, it's not like because you are doing anything wrong. It's because it's the expected way of doing this type of research, is that you spent a lot of time cleaning up data, checking that like the data actually looks the way you think it looks, because there's always some weird exceptions, like we saw with the references, which was a very simple example. You think you've done a good job of extracting the data, and then it turns out there's yet another edge case where there's some information in there that you didn't expect. And yeah, I think it's
Preprocessing.
the first 80% of the work is cleaning the data, and then the second 80% is the actual analysis.
Okay, thank you very, very much, Bastian. I must be sincere. What I even appreciate most is the documentation that you have given to us. So many of our participants are new to somebody online. Who is that? Okay, maybe he's a facilitator. Okay, so like I was saying, what I appreciate the most is the documentation that I've given to us, because it can always be referred to. So I just hope the document will always be online. Is that true?
Yeah, all of this is online. Like we put the link.
Yeah, we
So
have the
not
link. I'm
only,
asking if it will always be online. Will it always be online, or later you remove it?
no, it will remain online, and it's all openly licensed so that you can use the code as a starting point for your own work. And so let me just share the screen very briefly again.
Okay.
So if you go to the materials, which like indeed will remain at this website that's already shared, so you don't need to worry about it disappearing. But the secret second bit maybe is that if you go to the About page, you not only see the licenses, but you also see that the materials are available on GitHub itself. And if you click on the GitHub link, you see that actually most of these documents are either Jupyter notebooks for Python that you can run directly in the POS system online, or the last one that was R is like a Quarto Markdown, which you can open RStudio, so you can actually directly like load the code into either RStudio or Jupyter notebooks to work there. So you don't even need to strictly copy and paste code. If you want to just try to reproduce all we did, all of this are actually code notebooks that you can run yourself online already. So if you go to the About page of the materials, you will find the link to GitHub, where you can also get the notebooks in the unprocessed format.
Okay. Thank you very much, Bastian. Personally, I'll keep relating with you and communicating with you, most likely for future projects. Yes. I'm working on a novel product. Okay, I will share it with you on deep learning activation function. So I think I'll share with you later on. So the fact is that everybody can also communicate with Bastian. You're free to relate to him. His LinkedIn is open. You can always message him, and I believe he will be willing to collaborate in any way with anybody. So thank you very much,
Yes. So
Bastian.
if people have like during like the rest of the week or also next week have any questions how you can use any of these things in your